Hello students, I'm back with few more formula results and shortcuts of Trigo. I hope that all of you have watched my previous videos of trigonometry, that are trigonometry 1 and trigonometry 2. I'm sure that these videos will be beneficial to you. Now look what is written here, componendo and dividendo. And what is that? This is your numerator of LHS, denominator of LHS, numerator of RHS, denominator of RHS, and componendo and dividendo is also known as C and D. And what is that? After applying, if I apply C and D, that is componendo and dividendo, and that is numerator plus denominator upon numerator minus denominator, or according to the question, you can also apply this by numerator minus denominator upon, by doing this, numerator plus denominator, both ways. Okay, now if I apply C and D in equation 1, so what I get, numerator plus denominator upon numerator minus denominator, RHS numerator plus denominator upon numerator minus denominator. Now what else we get from here? If I apply component dividend again on this equation 2, then I'll reach back to equation 1. How? If I apply C and D in equation 2, so what I get, numerator plus denominator upon numerator minus denominator on our RHS, numerator plus denominator upon numerator minus denominator. This gets cancelled out with this, x by x, b, b, a. What we get, 2x upon 2y is equal to 2a upon 2b, or x upon y is equal to a upon b. So instead of applying component, if you get this type of equation, then instead of applying componendo and dividendo, you just break it into numerator and denominator. As you know, if I apply, I'll reach back to equation 1. So break it, this is your numerator and this is your denominator, numerator. And so instead of applying, you just write numerator upon denominator on LHS and numerator upon denominator on RHS. So this is what about componendo and dividendo. Now what else is written here? Alpha plus beta and alpha minus beta. If I add these two, from adding I get, if I add 1 and 2, I get 2 alpha. And if I subtract these two, then I get 2 beta. So you will be able to make out that whenever alpha plus beta and alpha minus beta is given, by adding I get 2 alpha, and by subtracting I get 2 beta. Now again, check this, that if x plus y and x minus y, and you have to reach back to x and y, then in that case what we get, by adding 1 and 2 I get 2x, and by subtracting 2 from 1 I get 2y, and after dividing this by 2 I'll get x, dividing this by 2 I'll get y. So you can easily get x from x plus y and x minus y. How? Add and divide by 2. You can get y from 1 and 2 equation by subtracting and then dividing by 2. So I hope it's clear to all of you. Now we are going to apply these results in this question. Now look, whenever, now I'm solving this question, and afterwards we generate a technique to solve this type of question. Now, how? If tan A is equal to x tan B is given, I can rewrite this as given condition by tan A, take this to left side, tan B is equal to x upon 1. Okay. Now, what is your hint? Whenever tan of two angles, ratio of tan of two angles, that is tan A upon tan B is given to us, and you have to find the ratio of sine of their difference and sine of their sum, then that question is always of componendo and dividendo. What I said, if ratio of tan of two angles is given and you have to find the ratio of tan of difference and tan of sum of those angle, then in that case we have to apply componendo and dividendo. Similarly, if tan ratio of tan is given and you have to find the ratio of cos of sum of the angle and cos of difference of the angle, then again you have to apply componendo and dividendo. Now look how. If I, this is solution of first, apply C and D, I'm just solving this in order to learn this result. Apply C and D in equation 1, and C and D is numerator plus denominator upon numerator minus denominator, and on RHS numerator plus denominator upon numerator minus denominator. And what do you do here? Tan A is replaced by sin A upon cos A. This tan B is replaced by sin B upon cos B. Similarly, in denominator, sin A upon cos A minus sin B upon cos B. And on RHS, I have this. When I take LCM, what I get? This is sin A cos B plus sin B cos A upon cos A cos B. Similarly, in denominator, what I get? Sin A cos B minus sin B cos A upon cos A cos B. Further solving, what I get? These two gets cancelled out with each other, and this is an identity. Sin A cos B plus sin B cos A is sin of A plus B. And in denominator, I have sin A cos B minus, that is sin of A minus B. And on RHS, I have this. And when I reciprocate both the sides, I get the answer this. Or you can apply componendo and dividendo here as numerator minus denominator upon numerator plus denominator, then you directly get this. So next time when you get this type of question, you just apply componendo and dividendo and checking if differences, then you have to do numerator minus denominator, and if there is sum in denominator, then numerator plus denominator is in sum. So next time, whenever you see that ratio of tan of angles are given and you have to find the ratio of sine or ratio of cos, you have to apply componendo and dividendo in that type of question. Now look, what is written here? This is a big question, but you directly conclude the answer from the previous question. What is written here? I am just writing the given quantities. If angle theta is divided into two parts such that means theta, let angle theta is divided into two parts, and that means theta is equal to alpha plus beta. These are the two parts. Next is given that tan of one part is k times the tan of other part. That means tan of alpha is k times the tan of beta. And alpha, and sorry, phi, this is phi. Phi is their difference. Okay. So what I am writing here, phi is equal to difference of those two parts. Those are alpha and beta. That means phi is difference of, phi is their difference of two parts. Now what do you have to find out? You have to find out sine theta upon sine phi. Sine theta is sine of alpha plus beta, and sine phi is sine of alpha minus beta. And from the previous question, you can directly conclude that here ratio of tan of angles is given to us k by 1. So ratio of sine of sum of the angle upon sine of difference of the angle is componendo and dividendo. So this is my answer. I think this is clear to all of you, that the value of this is k plus 1 upon k minus 1, because they are asking the same thing which is written in question number 1, but they have given us in the form of statement. Okay, now next, what is written? Now if instead of sine of sum of the angles is equal to m times sine of difference of the angle, that means I can rewrite this as, and what do you have to find out? Tan of sum of the, if suppose this my angle is alpha and this is beta, and adding 1 and 2 I get alpha plus beta, that comes out to be 2 theta, and by subtracting I get alpha minus beta, and on RHS I get 2 phi. Further dividing this by 2 I get theta, and further dividing this by 2 I get phi. So what they have written, add those angles, those are these, and then divided by 2, subtract these two, and then divided by these. Again, my question is of componendo and dividendo. That means tan theta upon tan phi is m plus 1, that is numerator plus denominator upon numerator minus 1. You can check it. How? I'm just solving it to just, that will make you learn it easy, that will make the process of learning easier. Okay, so I'm just solving it. How I solved it, this is given to us, sine theta plus phi upon sine theta minus phi, and if I apply componendo and dividendo here, I get sine theta plus phi plus sine theta minus phi upon sine theta plus phi minus sine theta minus phi is equal to, on RHS, C and D. Now this is 2 sine C plus D, and as all of you know, when I add these two I get 2 theta. C plus D by 2 sine cos C minus, when I subtract these two I get 2 phi, and that divided by 2. In denominator, this is sine C minus sine D, and I get cos C plus D by, that is 2 theta by 2, and sine C minus D, that is 2 phi by 2. These two gets cancelled out with each other. This gets cancelled out. What we are left with, this is sine theta upon cos theta, and this is cos phi upon sine phi. So that is tan theta into cot phi is equal to m plus 1 upon m minus 1, or tan theta cot phi is 1 upon tan phi is m plus 1 upon m. So there is no need to solve this, but we should know that how we solve this. Therefore I solve this. You just directly write this. That means what I get, this process holds both ways. Whenever ratio of tan is given and you have to find the ratio of sine or cos, you have to apply componendo and dividendo. Whenever ratio of sine is given to S and you have to find the ratio of tan, then again you have to apply componendo. Instead, if they have given to you ratio of cos and you have to find the ratio of tan, again you have to apply componendo and dividendo, but you have to be careful in that case. Just solve it the way I solved here. because there you find a difference. Instead of m minus 1, you get 1 minus m. So try to solve that. Okay, so if ratio of cos is given and you have to find the ratio of tan, so better is to solve. Otherwise, there again we have to apply. And how do we solve that? By applying componendo and dividendo. I think this technique is clear to all of you. This is the shortcut. This we apply componendo and dividendo. Okay, now next, what I have written here, Pythagorean triplets. And just to remind you, you have to learn few of the Pythagorean triplets. As already I told you, those are 3, 4, 5, 5, 12, 13. These are very common Pythagorean triplet, and you should know these triplets: 7, 24, 25, 8, 15, and 17. 6, 8, and 10, and one more, 2, 21, and 29. These are few common Pythagorean triplet and will be helpful to you if you learn these. Now look, what is? If I have to solve this, then I can, whatever I have told to you applied here. Look, alpha plus beta and alpha minus beta, and from these two you can obtain 2 alpha by adding these two. I already told you this. Okay, so one hint is I get 2 alpha. How? By adding 1 plus 2. Look at this. Clear? Now what? You have to find tan of 2 alpha. This question was asked in IIT JEE. Now tan 2 alpha can be expressed as the sum of alpha plus beta plus alpha minus beta. And you know, tan of this is what tan of x plus y, and the formula of tan of x plus y is tan x is your alpha plus beta, tan y upon 1 minus tan x into tan y. I think it's clear. Now, how do we get tan alpha plus beta and tan alpha minus beta? Here, alpha and beta both lies in between 0 to pi by 2. That means both are in first quadrant. Okay, so that will make you easy to find the value of tan of alpha plus beta from cos, because you know that cos is base upon hypotenuse, and according to this Pythagorean triplet, my perpendicular comes out to be 3. You know that this is the Pythagoras theorem, and you can find out, but as if you know this, you can directly find out. So that is 25 minus 16 root 9. Therefore I told you to learn these Pythagorean triplets. So my perpendiculars is 3, therefore my tan of alpha plus beta comes out to be perpendicular upon hypotenuse, that is 3 by 5, because I need tan alpha plus beta here. Now from what is given to us, sine of alpha minus beta, that is 5 by 13, and this is perpendicular upon hypotenuse, and base here comes out to be 12, because this is the Pythagorean triplet we are using here. So tan of alpha minus beta comes out to be base perpendicular upon base. What is it in here? Perpendicular upon base. This is wrong, no? So this is okay. So tan of alpha minus beta is here perpendicular upon base. Perpendicular is here 5 and base is here 12. So this comes out to be 5 by 12. Now put these value in equation 3. Put in equation 3. So that is tan of 2 alpha, because I have written tan of 2 alpha is tan alpha plus beta plus tan alpha minus beta. So tan of 2 alpha is tan alpha plus beta, what I get is 3 by 4, and tan alpha minus beta is 5 by 12. Now put these value, this is 3 by 4 plus 5 by 12. And here 1 minus 3 by 4 into 5 by 12. Now 12 into 3. So what I get, this is 48 minus 15 upon 48. So my answer comes out to be 56 by 33. Okay. Now next. Very, very important formula. And what is written here? And very easy to learn these. How, what is written here? Cos alpha. Next is cos alpha plus beta. Next is cos alpha plus 2 beta. Next one is cos alpha plus 3 beta. Dash 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 still cos alpha plus n minus 1 beta. Look at this. This ends at n minus 1 and begins at 0. I think it's clear to you. 0 alpha. You can write this alpha plus 0 beta. That means from 0 to n minus 1 we have n terms. Just to make you clear, if we begin from 0 and n to n minus 1, in that case we have, this is from 0 to n minus 1, we have n terms. Okay, because we need here n, the value of n. Why? Because on RHS, if you get this type of expression, then your RHS is sine n beta by 2 upon sine beta by 2 cos 2 alpha plus n minus 1 beta whole divided by 2. Now next formula is similar. What is the difference? In the previous one there is cos plus cos plus cos, and the relation of angles are this type. And in second one, what is sine alpha plus beta plus sine alpha plus 2 beta, then sine alpha plus 3 beta till sine alpha plus n minus 1 beta. Again here number of terms are n. And on RHS, look at the similarity. Again here we have sine n beta by 2, sine beta by 2. What is the only difference? That instead of this cos we have sine here. Rest is same. That is sine 2 alpha plus n minus 1 beta upon 2. That means in order to use, first of all you have to learn this formula, and in order to find the answer you have to find the value of alpha, beta and n. If you are able to find these values, then put on the RHS of these two formula. Now look at this question number 5. This is the application of this formula. Now first of all, I'm rewriting the question, that is pi by 11, then 3 pi by 11, and then 5 pi by 11, and then cos 7 pi by 11, and then cos 9 pi by 11. So here alpha is pi by 11 and beta is here 2 pi by 11. How? Just check it. This is cos of alpha. This is cos of alpha, that is pi by 11 plus 2 pi by 11, and you easily get 3 pi by 11 by taking the LCM. Next is this 5 is replaced by pi by 11 plus 2 into 2 pi by 11, that is 4 plus 5. I think it's clear to you. Next is pi by 11 plus 3 into 2, that is 6 plus 1, 7. And the next one is cos pi by 11 plus 4 into 2, that is 8 plus 1. So I think this is clear to all of you. So that means you are able to find out alpha, that is here pi by 11. You are able to find out beta, that is this 2 pi by 11. And in order to find number of terms, it is easier to count the terms 1, 2, 3, 4, 5. Or you can check this, that this is alpha plus 0 beta, 0 to 4 number of terms are 5. So now I'm putting all these value on the RHS of this formula. Now look, and your answers are in number. That means you have to do further few more transformations in order to get answers in number, and those are, now look at this. I'm applying this formula. Sine n is here 5, so that therefore I put 5. Beta is here 2 pi by 11. Further you have to divide it by 2, therefore this is 2. Then you write sine of beta is here this 2 pi by 11, and then you have to divide it by 2. I divided by 2. Now next cos 2 alpha. Alpha is here pi by 11, so I write here cos 2 pi by 11. 5 minus 1, that is 4, and beta is 2 pi by 11. Now what we get from here, this 2 cancel out by this cancel out by this, and we are left with sine 5 pi by 11. And what is this? 4 into 2, 8 plus 2. That is, and whole upon 2. I missed this. So this is 8 plus 2, 10 upon, so this comes out to be 10 pi by 11 upon 2. That is again 5 pi by 11. So this is cos 5 pi by 11. And in denominator, I have sine pi by 11. Now, after checking the options, I conclude here that my answer is only in angles, and there must be some relation between numerator and denominator so that we can cancel out these two. So what is the relation we are able to find here? What is written here? This is sine into cos, and there is a formula that is 2 sine theta, product of sine into cos is sine of 2 theta. So we know that this is the formula. That means there is application of this formula here, and for that you have to divide and multiply numerator by 2. That means I have written this. Okay. Now I'm turning to the next page. This is 2 sine A cos B. After applying this, 2 sine 5 pi by 11 cos 5 pi by 11 comes out to be sine 2 into 5 pi by 11. That is 10 pi by 11. So now I'm turning the page. So what I get here, okay, I get 1 by 2 sine 10 pi by 11, and in denominator I have sine. Further, I have to look for another identity or relation that we use, and we cancel out these sign with each other. That is, you can write this 10 as pi minus pi by 11. Look, 11 minus 1 is 10. So you can change this. When I take LCM, this comes out to be 10. 11 minus 1, 10. 10 pi by 11. So I just relate numerator and denominator in this way. And as all of you know that sin pi minus theta is second quadrant is sine of theta. Therefore, this comes out to be sine pi by 11, sine pi by 11, and my answer is 1 by 2 only in numbers. So this is my answer. I think this question is clear to all of you. Okay. I hope you have gained a lot from this video. Give this video a big thumb up and share it as much as you can. Make sure to subscribe the channel method wise and hit the bell icon. Thank you.